Hi, I'm John with Page Tutoring, and today we're going to cover Eduqas' Mathematics GCSE Autumn Term Paper from 2023, Foundation Tier. So, before we fully crack in, it's always worth just having a quick review of the front page. So this will tell you how long the exam's going to be, so that's 2 hours 15 minutes. With this being the non-calculator paper, this counts for 50% of your total grade. This paper is marked out of 120 marks and has 32 questions. To get the maximum grade you can get on this paper, with it being a foundation paper, that's grade 5, the mark scheme for this year in autumn was 72. So you only need to get 72 marks out of 120 to get our grade 5. The boundaries between these grades is about 10 marks. So for each mark that you get in this paper, that's 10% closer to that next grade boundary. That's always good to keep in mind. Now, looking at just get the laser pointer, looking at the additional materials section here, if you're ever in doubt of whether a question might need you to use a ruler or a compass, you can always have a quick check of this additional materials, check that that's what it's asking for. Going to the next page, you are given a formula list. So I'm just going to zoom in a little bit here so we can see a little bit better. So this formula list, we just have some areas and volumes. So that means you don't need to memorize them. You have them given to you, and you have some kinematics formula. So these are formula used for calculating distance and speed. Without further ado, let's get started. So starting with question 1, for non-calculator papers from Eduqas, you will always have a question starting with some basic arithmetic, some basic mathematics to try and get you some easy questions to push you past that initial grade boundary. So starting with 1AI, so we're going to work out the following: 20 times 40. For anything where it's multiples of 10, what I do is I just ignore the zeros, ignore the fact it's a multiple 10, and go, okay, what's 2 times 4? I know that 2 times 4 is 8, and then I'll add back in the zeros. So I will know that's 8, and then 2 zeros, 800. So now we're going to do 57 divided by 3. Well, I know that 60 is 20 times 3, because I know that 3 times 10 is 30, 2 lots of 30 is 60, so 60 must be 20 times 3, and that's 3 less than 60, so that must be 19. Now we've got a fraction coming in, so we've got 2 over 5 of 30. So what we can do in this case is I would find out what 1/5 of 30 is first. So we can do that by doing 30 divided by 5, which is 6, of course. And we want 2/5 of 30. So all we need to do is times that by 2. So 2 times 6. So now we get 12. So scrolling a little further down, now we've got 30% of 70. Well, first of all, let's find out what 10% of 70 is. That's much easier than going straight to 30%. So 10% of 70 would be 70 divided by 10, which gives us 7. So 30% of 70 must be 7, which is our 10%, times by 3, which gives us 21. For question 5, we have some numbers with decimal places. Now this is checking that you can keep track of where the decimal places is and they don't shift. So if I write out, so we're going to add these together, 1.03, what can end up happening when you write out that next line is the decimal place, that dot here, ends up moving left and right, and people get a little bit confused. So to stop that confusion, we're going to add in these extra zeros that I'm just going to write in red, so we can see that I'm just adding these in so I don't get confused. Doesn't affect the actual value of the number, just keeps your decimal places in check. So we're adding these together, so we get 3, 8, 3, 1. So that here is our final answer, 13.83. So going on to part B of question 1, we have got write 8% as a decimal. Well, we know that 8% as a decimal would be 0.08. And we know that because if we times that by 100 to switch from decimals to percentage, that's what you do. You times a decimal by 100, that would give us the 8%. So, part C. In the box, write the smallest possible whole number to make the statement correct, with the key word here being whole number. So we don't want it to have a decimal place. So the smallest whole number we could write would be 5. Now for question 2. So this question tells us a bunch of information about factors. So it says most numbers have an even number of factors, and then it gives you some examples. So for 10 has 4 factors, 1, 2, 5, 10. 11 has 2 factors, 1 and 11. So they both have an even number of factors. But then the question goes on to tell you that there's one number between 13 and 19 that is an odd number of factors. Find this number. So that's not something that you're going to know off the top of your head. This will be a case of trial and error, keeping in mind that it's only 2 marks. So really, you shouldn't be spending more than 2 minutes on the question. So if you're going for ages and ages trying to brute force this and you're getting nowhere, it's best to just leave this till last if you have any extra time. If we just start going through, so there's one number between 13 and 19. So that gives us 14, 15, 16, 17, and 18. Now, straight off the bat, one of these numbers is a prime number, and we know that prime numbers only have 2 factors, so we don't need to bother with that. And that number is 17, in which case we'll start with 14, and we'll just start writing out the factors. So that would be 1 and 14, keeping in mind that these factor pairs that I'm writing out, when you multiply them, it will give you the original product, that 14. So we could do 2 and 7, and that's all the factors. So that is an even number, so it's not that one. So we'll try 15. So we can do 3 and 5. We could do 1 and 15. And that's it. So it's not that one. We could do 16. So you can do 8 and 8. 1 and 16. 2 and 8. Apologies, the first one is not 8 and 8. Of course, to get 16, you times 4 and 4. So let's have a look. Is there any more there that we've forgotten? No, that's it. And because of 16 being a square number, we can see that of these factors, the unique numbers we have is 4, 1, 16, 2, and 8. So 1, 2, 3, 4, 5. We have 5 factors here. There's our odd number. Nice. So we can stop right there. We don't need to do any more work. We've found it. So the number is 16. The factors of this number are 4, 1, 16, 2, and 8. Part B then asks you to write down the first 3 even multiples of 7. So it's giving you a little bit of room there, so you can just start writing out the multiples of 7. So you could go 7, 14, 21, 28, 35, 42. And I'm not going to write out any more because we've already gotten to our first 3 even numbers. So we've got 14 there, 28 there, and 42. So we can write them into our answer slot. So now we're on to 2, part C. This question is testing if you know how to round. So if we're going to get to 25 from the nearest 5, you could either round down to that or you could round up to that. If we were to round up, then anything greater than 22.5 would round up. For rounding down to 25, anything less than 27.5, you would round down. And these numbers of 22.5 and 27.5 have come from half of 5, which is 2.5. So with rounding, if you're at the halfway point, you round up. If you're less than the halfway point, you round down. And that's all there is to it. So with that in mind, and because there can only be a whole number of pupils, we can't have decimal numbers, that means that it must be either 23, 24, it could just be 25 itself, so we could have just 25, 26, or 27. Question 3. So question 3 doesn't have any parts, it's a question on its own. And it asks what percentage of the following shape is shaded. So the trickiness of this comes from the fact that this shape has, let's count, so 1, 2, 3, 4 down. So we'll mark that on here, so 4 down. And it has 1, 2, 3, 4, 5 across. So that is 20 boxes. And of them 20 boxes, you have 8 that are shaded, which means 8 out of 20 shaded. You can write it as a fraction like this. We can simplify that fraction, so we could get 10 over 4. It simplifies to 2 out of 5. But then that's just a fraction. That's not a percentage. So to convert that to percentage, let's first convert our 2 over 5 into a decimal, which would just be 0.4. And we can see that from our 4 over 10 here. That makes sense. If we divide 4 by 10, that goes to 0.4. Now to make that into a percentage, we're just going to times it by 100, which gives us 40%. That's your final answer. That's the end of that question. Now question 4, straight off the bat, has loads of information that it's written down for you. So a teacher asked a group of students to choose their favourite sandwich filling. The 5 options were cheese, chicken, ham, salad, or tuna. Each student chose just one option. So each one of these values corresponds to one student. The table and the pictogram, so the pictogram is the one with the shapes, each show some of the results of the 5 fillings. So we scroll down, you've got a key and a whole circle represents something amount of students. So it tells us complete the key, the table, and the pictogram. For completing the table, we have to look at the pictogram and figure out how many students each full circle represents. And then looking at the table, we can use that amount, for example, 3 for cheese, to then fill in the pictogram. Starting with the only place in the table and the pictogram where we have all the information, the salad. So that salad, there's one student who's having the salad, and that corresponds to a quarter of the circle. So cool. Now we know that a quarter of that circle equals 1 student, which means 4 quarters, so a full circle must represent 4 students. So now we can start drawing on our pictogram based on the information we have in our table, these shapes. So if we have 3 cheeses, that means we have 3 quarters of a circle. Whoa. There's my not that neat drawing, but you could draw on the lines so you can show that you're showing 3 separate quarters. And then for tuna, we've got 6. So that would be 1 full circle and then half a circle. Just to make sure, you could just draw in your lines so the examiner can see that you've put 4 quarters there, 2 quarters there. So we finished our pictogram. Now looking at our pictogram for chicken, we've got 2 full circles and a half circle. So that means we've got 4 students here, 4 students here, 2 students here. So in total, we've got 10 students. We can write that in our table. For ham, we've got 3 full circles. So that's 4, 4, and 4. So 12 students in total. So that is the end of part A. So we've completed the table, the key, and the pictogram, and there's some room at the bottom to do some writing. So if you wanted, just to make sure, just in case you have a very mean examiner, you can write your working out of that 1 quarter equals 1 student, and you can write that you got that information from salad. To part B. What is the modal choice of sandwich filling? Well, the modal is the most popular sandwich filling, and that would be, looking at our table, ham. So we can write down ham. Question 5A. Lucy writes down the first 5 square numbers. Lucy chooses 2 square numbers that have a difference of 12. Which square numbers did Lucy choose? So to start with this question, let's do exactly what Lucy did. What are the first 5 square numbers? Well, you could do 1, so that's 1 times 1, and we'll do 2 times 2, which is 4, 3 times 3, which is 9, 4 times 4, which is 16, and 5 times 5, which is 25. And now we're looking for ones where there's 12 difference. Let's have a look. Well, the difference here, we can see that's 3, 5, and then that's 7. Difference here, that's 5, 9. So we can see that it's not consecutive numbers. It's not going to be 2 square numbers that have come after each other. So let's now start doing every other one. So we compare 1 and 9, that's 5. If we compare 9 and 25, that'll give us 16. So we know it's not them. Doing this method of doing every other number, there's only 2 numbers we've not done, and that's 4 and 16. So the difference between 4 and 16, voila, would be 12. So now the 2 square numbers are 4 and 16. So we've solved that through process of elimination. Part 5B. Mary adds 2 odd numbers together, gets an answer of 21. Could Mary's answer be correct? Well, let's first think. 21, well, that's an odd number. And we should know from basic arithmetic rules that to get an odd number, you'd have to add an odd plus an even. That gives us an odd. Because we know that an even plus an even and an odd plus an odd equal an even number. So there's no way that she can add 2 odd numbers to then get another odd number. That's just not how it works. So could Mary's answer be correct? No. So moving on to 5, part C. Write the following values in ascending order. So this is testing if you know what them decimal places there mean. So starting off, all these other numbers except for 3 are a decimal place of 0 point something. So 3 is the biggest number there. The smallest number would be 0.30, just 0.3. Because 0.302 is bigger than 0.3. It's bigger by 0.002. And we could find that if we were to take them away from each other. But there's only 1 mark here. We don't need to do that. So the next biggest number would be 0.35. So that's about 0.05 bigger than the previous number. And then the last number that we have is our 0.8. And to keep track, feel free to circle off these numbers as you write them down. Question 6a. Just going to zoom in a little bit so we can read it a little easier. 25 players in a rugby team voted for their player of the season. The 3 nominations for players of the season were Ashton, Jamal, and Oliver. The frequency table shows the tally of the votes from 10 of the players. So 10 people voted, there's 3 people who they could have voted for, and this shows which player they voted to be the player of the season. So the remaining 15 votes are shown below. So we've got like a nice list of the names that people have voted for. Which player won the vote for player of the season? You must show all your working out. What it's asking you to do, it shows the remaining 15 votes here are below. They've not been tallied up yet. In the table, it's giving you an example of how you would tally them up. So what we're going to do is just complete that table. We're going to add these votes to the table. So now that I've tallied them all up, just gone through each one, a little bit tedious, we're just going to tot up at the end what the frequency is. So what the total number of tallies are. So for Ashton, we have 7. For Jamal, we have 10. And for Oliver, we have 8. So which player won the most votes? We can say Jamal, because he got 10 votes. And you must show all your working out, but we've got our working out in this table here. So we could even say, so our final answers go here, as he got 10 votes. So moving on to 6a. What percentage of the 25 students voted for Oliver? Well, if we have a look here, so all 25 students voted. We can see that by looking at the frequency and seeing that 7 voted for Ashton, 10 for Jamal, 8 for Oliver. That tots up to 25. Okay, so we're happy everybody voted. So now out of 25 students, I'm going to write this as a fraction, 8 voted for Oliver. So let's simplify that as much as we can. But to make it simpler for our question, we could actually times the top and the bottom by 4. This is a sneaky little trick. 4 by 4. So then we get 32 over 100. Well, because we're good at our percentages, we know 32 over 100, that's just 32%. 6, part B. Some of the players in Lindsay's team have missed games because of injury. That's not great for them. She writes a question to find out how many games they have missed. Here's the question. How many games have you missed this season due to injury? 0 to 2, 2 to 4, 5 or more. So a very simple criticism that I can see straight away, okay, I've managed to break one leg and I've broken the other. I've had 2 injuries this season. Which box am I meant to tick? Am I meant to pick 0 to 2 or am I meant to pick 2 to 4? The boxes overlap, so this isn't a good survey because I don't know which box to tick. Because if I tick the previous one, that could suggest I have no injuries. If I tick the next one, it could suggest I have 4 injuries, but I have 2. You would write down the box options 0 to 2 and 2 to 4 overlap. Question 7, part A. Robin has a scale drawing of his local park. The scale in the drawing, 1 centimetre represents 250 centimetres, so 2.5 metres, thereabouts. On the drawing, a flower bed is 6 centimetres long. What is the actual length of the flower bed? Write your answer in metres. Oh, there we go. So before I've even finished the question, I've kept in my mind, I know, and you can write this down, because this may get you marked, you never know. So 100 centimeters equals 1 meter. Okay, well, first step, we've got a conversion here. So we know that 1 centimeter on our map converts to 250 centimeters in real life. So that's map, and that's in real life. So on the map, our flower bed's 6 centimeters, which means in real life, it'll be 6 times 250 centimeters. We should put FB for flower bed. So that will equal 1,500 centimeters. So that's just some quick mental maths that I've done. So I know 5 times 250 is 1,000, and then 2 times 250 is 500, and I've just added them together, 1,500 centimeters. So now let's convert that to meters, because it wants its final answer in meters. So if 100 centimeters equals 1 meter, all we need to do is divide our final answer by 100. How many lots of centimeters are in there? That is 15. It's a huge flower bed. So 7 part B. Robin has 240 daffodils and 60 tulips. A lot of daffodils, a lot of tulips, but it makes sense he's got this huge flower bed. What fraction of these flowers are daffodils? Give your answer in its simplest form. So the total number of flowers we have, total number, would be 240 plus our 60. So it doesn't matter what type of flower it is, daffodils or tulips, we want to know the total number of flowers in general. So that gives us 300. So of our flowers in general, 300, how many of them are daffodils? Well, it says there 240. So 240 over 300, we've got a fraction now that we can simplify. So let's see how simple we can get it. Let's divide by 2 first. Start getting this down to something a little easier. So 250 and then 120. And then we can divide by 10. So we could have 15, 12. We could divide by 3 then, because 12 and 15 can divide by 3. So we get a 5 and we get a 4. And we can't get any simpler. So that's our final answer there. Simplest form. Some rose bushes, so part C, some rose bushes are divided equally between 2 gardeners. Write this division as a ratio. Well, this is giving me pause there because it almost seems like a trick question, but they're not trying to trick you. They're trying to see if you understand basic ratios. So if you've only got 2 gardeners, imagine 2 guys, you've got a bunch of rose bushes. How are they going to split it? Well, you'd split it equally. You want it to be fair. So it'd be 1, 2, 1. Each gardener gets an equal amount of work. Question 8. A shop sells the same brand of lemonade in 2 different size bottles. So we've got our diagram of the bottles there. So one's 1,000 millilitres for £2.50, and one's 300 millilitres for 81p. Which bottle is the better value for money? Well, at the moment, we can't really compare them because they're different weights, they're different amounts of fluid. So we can't directly compare them. But if we can figure out how much an equivalent amount of fluid is worth in each case, then we can compare them. Because we've got 1,000 millilitres here and 300 millilitres here, I'm going to try and figure out how much this, so I'm just going to call it brand A, just to make it easier, and I'm going to call the small one brand B. I'm going to find out how much for brand A 300 millilitres would cost. So starting off, so we've got 1,000 mil equals £2.50. So I'm going to divide by 10 to find out how much 100 millilitres costs. So that would be 25p or 0.25 pounds. So now I'm just going to times by 3 to get 300 millilitres, which would be 0.75 Or, so now bottle B is stated in pence, but we know that 0.75 pounds, that's the same as 75p. So for bottle A, the 100 milliliter bottle, it would cost 75p for the equivalent amount of fluid as bottle B, the 300 milliliter bottle. So the 100 milliliter bottle is better value for money. Question 9. Just at a glance, we can see we've got a lovely bit of algebra here. So now if I zoom in to 9a, solve 6x equals 42. So we want to get x on one side on its own to find out what its value is. We're going to do the same things each side of this equation. So 6x equals 42. We're going to divide by 6 to get rid of that 6 in front of the x. So that would give us 6 equal to 7. And that's the end. You've solved that equation. 9b. Calculate the value of 4y when y equals minus 12. So this is a nice substitution that's trying to trick you. Because if I do 4 and I just slotted that minus 12 in without any brackets, some people would mistakenly put minus 8. But always remember when you're doing a substitution, put in them brackets there, which means 4 times minus 12, which would then give you minus 48. Next, we're going to simplify. So simplify just means expand out the brackets, collect like terms. So we've got 5w plus, first we're going to do 3 times 6w, so that's just 18w. And then we get minus 6 from 3 times minus 2. So now we can collect w's together, so that would be 23w minus 6. So lastly, part D. A shirt has T buttons. Write down in terms of T the number of buttons on 8 shirts. So we'd have 8 times the number of shirts, so 8 times shirts. If each shirt has T buttons, then it would be 8 times T, and with knowing algebraic expression, it'd be 8T. Question 10. Here's a number machine. So this is quite a common type of question that you'll see in your Eduqas maths papers. And the number machine is almost like another way of thinking about algebra. So how does this number machine work on this question? So you put your input in, so whatever number you want, you're going to subtract 3, then multiply by 5, and then you'll get your output. So question 1 is, the input is 10. So we're going to write down 10, that's what we've put in our number machine. What is the output? So if I zoom in, see a little bit here, we've put in our 10. Next step in our number machine, we're going to subtract 3. So that gives us 7. We go to our next step and multiply by 5. That gives us 35. And then that's the end. That's our output, 35. Nice and simple. Now it says that the output is 55. So what we get at the end over here now is 55. What's the input? So with this number machine, we're just going to work backwards in the exact order, but in reverse. So if we multiply by 5, first we're going to divide by 5. So that gives us 11. The next step, where we'd subtract 3, we're now instead going to add 3. So we started with an input of 14. Question 11. Adele and Lewis are shopping in a bakery. So you've got some lovely pictures, some bread rolls there. So we've got bread rolls. So if you're just going to get one bread roll, I'm just going to write the information next to the picture so we remember it's 98p. Or for £4.50, you can get a bag of 5 bread rolls. It's £4.50. Adele buys a bag of 5 bread rolls. How much money does she save compared to buying 5 rolls separately? Okay, well, we already know how much a bag of 5 rolls costs. They've told us in the question. So now we need to know how much would it cost if we bought 5 individual rolls. So 5 times our 98p. So 5 times 98 is not easy. But what is easy is 5 times £1. That just gives us £5. But for each of these pounds, we're actually 2p less. So we're going to be 5 times 2p less. So that's just 10p. So our 5 times 98p would just be £5 minus 10p, which would give us £4.90. Now at that point you might think, okay, I've done all that working out, I've figured out how much it's worth, I'm going to stop. That would only get you 2 marks. To get that final mark, you need to say how much she has saved. So you need to go £4.90, so that's the cost of 5 individual rolls, take away £4.50. So the final answer is 40p. Part B. Croissants cost 90p each, and cinnamon rolls cost £1.25 each. Lewis buys 4 croissants and some cinnamon rolls. Lewis has £10. Okay, so we're going to write down Lewis here, and we're already going to start writing out some of this information so we have it available to us. So Lewis, he has £10, and he's bought 4, and we're gonna, for croissant, we're gonna write C. Cinnamon rolls, we're gonna write W. He's got 4C plus, we don't know how many cinnamon rolls he's gonna get, so he's got something, mystery box, rolls. What is the greatest number of cinnamon rolls that Lewis can buy? You must show all your working out. So he's got a tenner and he's determined to get rid of that tenner. He's going to spend it all on these baked goods. Well, we already know that he bought 4 croissants. So how much are 4 croissants worth? So that's 4 times, and it tells us here, each croissant is 90p. So he has just spent £3.60 on croissants. So out of his £10, he's already spent £3.60. So he has left £6.40. Each cinnamon whirl is £1.25. Now we could divide £6.40 by £1.25, but it might be a little easier to work out if we just start subtracting £1.25 from £6.40. So if we do £6.40 minus £1.25 here, so this is our first whirl, we will get £5.15. We're going to do our second lot, so now we've got £5.15. I'm taking away 1, 2, 5. So that would give us £3.90. So now we're going to get our third whirl, do £3.90, take away 1.25 again. Each time we're just buying an additional whirl with the money we have left over. 5, 6, 2, £2.65. And then we can see just from the £2.65, we'll be able to buy another two whirls. Because if we do 2 times 1.25, That is £2.50. So let's see, amount for 2 wheels there. So we could buy 1, 2, 3, 4, 5. So 5 wheels. And then you would have 15p change. Question 12. A wind turbine generates 390 units of electricity per hour. How many units of electricity will this turbine generate if it continues at this rate for 2 hours and 20 minutes? So starting off, we have our 390 units per hour. If we want to know how many units is made in 2 hours and 20 minutes, we need to multiply that 2 hours and 20 minutes by 390. But because of that 20 minutes, we need to keep in mind that 1 hour is equal to 60 minutes. Therefore, that 20 minutes is a third of an hour. Now first we're going to do the easy bit. We're going to do the 2 hours. So in 2 hours, if we times that by our rate, which is up here, so 390 units per hour, we will make 780 units. And this equation makes sense because if we look at our units at the end, that units per hour, an hour, the hour for 2 hours, and the per hour for the 390 units per hour will cancel out and just leave the units of units. So now we're going to do the third. So a third of an hour times 390 units per hour. Well, timesing by a third is just the same as dividing by a third. So 390 divided by a third would be 1,300 units. And I know that because 30 has 10 lots of 3 in it. 9 has 3 lots of 3. And then the 0 at the end just means, so we add our 10, we add our 3. So 39 has 13 lots of 3. And then we whack the 0 on the end. That's 130. So the last step is just adding these together. So that gives us 910 units. Question 13a. Ben needs 90 bottles of water for an athletic event. That makes sense. You do a lot of running, you need water. The bottles of water are sold in packs of 8. He makes this calculation to find out the number of bottles he needs. So he's done his 90 bottles of water that he needs, and he's divided it by 8, which he's got from the number of bottles of water in a packet, and he's got 11.25. So he decides to buy 11 packs of water. Is Ben's decision correct? Did he make the correct guess to get the 90 bottles of water? So we can check this really quick by going, okay, well, he got 11 packets of water, and each one of them packets you get 8 bottles. So that gives us 88. You'd have 2 bottles less than what he wanted, the 90. So that's 2 athletes who don't have any water. That's not good. That's not what he wanted. So his decision to round down at that point was incorrect because he's got 2 less than he should have. So you could even put there that that's less than 90. So part B of this question, Ben divides the 90 bottles in the ratio 4:1. He says to work out the larger share, we should divide 90 by 4. Explain what's wrong with Ben's method. Well, this is a very common mistake that people make with ratios, and they'll choose one of the numbers from one side of the ratio. So, for example, I'm going to write this in red because it's wrong. What Ben's done here is he's got this 4 from this 4 on this side. But with the ratio, in total, you have 5. So 4 plus 1. So if he was to divide this up and figure out the ratios, and we'll write this in blue because this is correct, Ben should divide by 5 to get the ratio value. So dividing by 5, that would tell you in this ratio, each 1 in the ratio would be worth, so if we did 90 divided by 5, that's 18. So each 1 in the ratio is 18, but he wants to figure out a larger share in the ratio. So now we've done 90 divided by 5. This is 18. For the larger share, it'd be 18 times by 4. So the larger part of the ratio is the 4 right there. So we're just going to times that by 4. Question 14. The table shows some of the values of y equals 1 minus 2x in the range of -2 up to 2. So you've got this table, and the table is incomplete, and this is quite a common question, usually, and in this case, they're going to ask you to complete that table. Now, how they've got them values in the table is they've just substituted that value of x into the equation y equals 1 minus 2x. And they've given you some room there so you can do that substitution. So if we're going to do for x equals -1, so this one here, so we're going to get y is equal to 1 minus 2 times -1. So that would give 3. Because the -2 times -1 will become just 2, and then you're adding 1, so that's 3. And then we're going to do that for 1. So we're going to put 1 x y equals 1 minus 2 times 1. So we're going to get -1. And if we're going to do for 2, y equals 1 minus 2 brackets 2, which equal -3. -3 and then -1. We've completed our table. Then part B says, on the grid, draw the line y equals 1 minus 2x for the range, and it's the range that you've just worked out with the table. So when it says draw this line, what it's actually asking you is to plot these points, plot the points that you've worked out up here. So you know that when you're plotting a point, it takes the form of x, y in these brackets. So for example, if we went for this first one here, that would be the coordinate -2 and 5. So now I believe, the grid's all on its own on the next page. So we're going to go back and forth a little bit, but that's okay. So we're going to plot -2 and 5. So -2 and 5. You draw a little x. -3 and 3. 0 and 1. You're starting to see a pattern of line here. 1, -1. So 2 and -3. So then you're going to connect this with a straight line. Just going to do a nice straight line all the way through all them points there. And that's all you've been asked to do. You've been asked to plot them points. So from the table, we've plotted the coordinates and then we've drawn a straight line through. Question 15. The bag contains 100 identically sized coloured balls. Eduqas and most maths facilitators really love the idea of just like a little bag full of marbles or balls or a mysterious object. And usually when you see this, and as you'll see as the question continues, this is a probability question. So a bag contains 100 identically sized coloured balls. A ball is selected at random. The table shows the probability of choosing a blue ball, a red ball, or a green ball. Show that the bag must contain 10 balls that are not blue, red, or green. Well, how can we show that? So So we know it contains 100 balls, and we could figure out the amount of each one of these balls by timesing our probability of picking one by the total number of balls. But we should know the probability should add up to 1. So what we can do, we could add up the probability of getting each one of these balls. So 0.42, 0.30, and 0.18, and see if that adds up to 1. So add there, and there. And we find that this is equal to 0.9. Probability here is 0.9, which means that there must be some other ball, we don't know what, that has a probability of 0.1, so all of these add up to 1, of some other mystery colour that we're just going to call X, we don't know what it is. So by adding up the probability showing they don't add up to 1, so we could just say not equal to 1, and then we can say 0.1 others. Question 16. Gary owns a garage selling second-hand cars. On Saturday, he had 72 petrol cars and 48 diesel cars for sale. So then part A says, write the number of petrol cars to the number of diesel cars as a ratio in its simplest form. Okay, well, we can start off by just doing a general ratio. We know that in his garage, petrol cars, so starting off with the petrol cars, the 72, to the number of diesel cars, that's 48. There's 2 marks in this question, so the second mark would be from fully simplifying. So exact same thing as you do with a fraction. Dividing both of these numbers by the exact same thing means the ratio stays the same. So we want to get it down to the smallest whole numbers that we can. So we're first just going to divide by 2. So I'm going to put divide by 2. And that would be 36 to 24. Okay, well now I could divide by 6. So I get 4 here, and I get 6 here. And I'm going to divide by 2 again. And then I'm going to get 3 to 2. That is the simplest form. So then it asks, what percentage of cars are diesel? Let's see. In total number of cars. So your total number of cars would be 72 plus 48. So that would give you 120. So then we know for the diesel cars, which is 48, we've got 48 out of 120 are diesel. Then you can simplify that down, and you'll go and go and go. And you'll find, like before I do anything else, this will simplify down. I can see 2 over 5. And I know that from my ratio. Because in total of the ratio, if you do 3 plus 2, you get your 5. So there's 5 things in total there. And out of them 5 things, 2 of them are diesel. So now we could convert that to decimal, which would be 0.4, which then if we times it by 100, we get 40%. Or we can skip that initial thinking step of getting the total and getting our fraction, and just look straight at our ratio, see out of 5 things, 2 of them would be diesel, so then we know 2 over 5, and then we do our final step. Question 17, part A. Calculate 12% of £750. So for doing percentages, what we could do is first find 1%. So if 750 is 100%, then 1% would be £750 divided by 100, which would give us £7.50. So then to get 12% from that, we just need to do 1% times 12. So that's £7.50 50 times 12. Now I can't do that all in my head. So what I would do is 7 times 12, 84. And I worked that out from, well, 5 times 12 is 60. And I know 2 times 12 is 24, so I just added them together. So then what's 0.5 times 12? Well, 0.5 times something is the same as dividing by 2. You're asking what's half of 12, so that's just 6. So then this will give you a total of £90. And that's your final answer. So then part B asks, when a fraction's added to 2 over 5, the answer is 7 over 15. Find the fraction that is added. So if I write this like algebraically, so I've got 2 over 5, and I know that something, like some sort of fraction here, added to it would equal 7 over 15. Well, a way I could figure this out is to get this fraction of 2 over 5 in the same form as 7 over 15. So if I times the top and bottom of 2 over 5, that fraction will be the same, but it'll look a lot more similar to 7 over 15. So let's do that first. So 7 over 15, we've got our mystery number here, plus, and we're just going to times this top and bottom by 3. So we'll get 6 over 15. Okay, that's a lot simpler because 6 over 15 plus something equals 7 over 15. So this mystery number here, we can see from observation, must just be 1 over 15. Because when you're adding fractions, if the bottom, so the denominator, is the same, so 15 and 15, then all you do is add the numerators together. So 6 plus 1, which would give us our 7 over 15. And that is 3 easy marks. Question 18. Sarah has a water container in the shape of a cuboid. Now, questions about cuboids containing water or pools or ponds, these are very, very common in maths questions. They really love it. So the area of the base of the container is 150 centimeters squared. So if we put ... just to give this more of a 3D perspective, so we know that this base down here, this area down here, is 150 centimeters squared, which also means that that top area there is also that. Water's leaking from the container at a constant rate. Okay, so at 10 o'clock, the water is 20 centimeters high. At 10:15, the water's 17 centimeters high. So in 15 minutes, it's lost 3 centimeters. How much water is in the container at 11? So at 10 is 20 centimeters, at 10:15 is 17 centimeters. When it's a constant rate, it means it's linear. It means it's going to change. If you were to plot its change, it'd be a straight line. So we've got our relationship. Every 15 minutes, it loses 3 centimeters. So we could say at 10:30, it would be down to 14 centimeters. Say at 10:45, it's down to 11 centimeters, which means at 11, it will be down to 8 centimeters. So now we've got the height of that water at 11 o'clock, 8 centimeters. And it says, give your answer in litres. And you might go, hang on, none of the other units are litres. What? But hopefully you have in the back of your head the conversion of 1 litre is equal to 1,000 centimeters cubed. Well, we know for a prism, which this cuboid could be counted as a prism, that for the volume, it's just its base times its length, or in this case, its height. So we know that the height here, 8 centimeters. We know that it's base, so the area is 150 centimeters squared. So to get that in centimeters cubed, we just need to do 8 centimeters times 150 centimeters squared, which is equal to, let's have a think. So 2 times 150 would be 300. So that would be 1,200 centimeters cubed. Now converting to litres, we just need to divide by that 1,000 centimeters cubed. We want to know how many lots of 1,000 centimeters cubed is in 1,200 centimeters cubed. Well, we can do that just straight away in one step. Dividing by 1,000 would just shift the decimal place 3 places, so you'd have 1.2 litres of water in the container. Question 19. 120 people each completed a puzzle. The times taken to complete the puzzle are shown in the diagram below. So you've got a nice bar chart there. The diagram uses groups of width 5 minutes. So less than or equal to 0 and up to 5 minutes. And then you'd have a group of less than or equal to 5 minutes up to just below 10 minutes and so on and so forth. You've got your nice little diagram there. So a person's chosen at random. What is the probability that this person took less than 15 minutes to complete the puzzle? So we're going to put a red line in there. So less than 15 minutes. So we've got 15 minutes there. Put that here. And we're looking for a probability. So probability, that's between 0 and 1. So the first step of this, we've put in our line. We want to find out how many people are on this side. How many people are in this bar chart? So what we're going to do is we're just going to look at each of these bars. We can see there's 20 here, just following along there. There's 30 here, and there is 40 here. So in total number where it's less than 15 minutes would be 20 plus 30 plus 40. So that's just 90. Okay, so we've got the total number of people less than. So then what's the total number of people in general? Was that given in our question? Let's have a look. 120, that's right at the start of that question. So total number is 120. So now we're going to write this as a fraction. So out of 120 people, we had 90 of them finish in less than 15 minutes. So now we're going to simplify this fraction. So you can make that 9 over 12, make that 3 over 4, and that's the simplest form. To write this as a decimal, that would just be 0.75. At that point, you can stop. That's less than 1. That is your probability that if you pick a person at random from this group, that they would have finished in less than 15 minutes. Question 20. The diagram below shows 3 straight lines, AB, CD, and GH. Now when the lines are notated like this, AB and CD and GH, it just means a line that goes between the points. So for AB, so between the points A and B. So it would then be this line here. Okay, and I say that because I've worked with a lot of students who have sort of struggled and failed at the first hurdle of knowing what that notation means. So now this is a geometry question, so it's going to be how these different angles relate to each other. So show that AB, so a line we just showed then, and CD, which would be this line here, are parallel. Now they've been particularly mean in this one because the way they've drawn it, though it says here diagram not to scale, it doesn't look parallel. But they're saying show that it is parallel, and they're trying to catch you out and trick you. And some students are going to go, they're not parallel, I can see by my eye. But it says right here, diagram is not to scale. You must give a reason, justify your answers. So the first step of this would be, okay, you've got some angles here. Well, you know, for opposite angles, so that's when you have two lines crossing over like that, and the opposite angles would be like this, are equal. That would get you 1 mark. And now applying that, so we can see that opposite angle here, that's 100. We can see opposite angle here, that's 80. We also know that allied angles add or sum to make 180. So in this case, an allied coordinate would be this 80 degrees here, and this angle, and this 100 degrees here, and this angle. So if they add to make 180, well, that must mean that this is 80 degrees. That must mean that this is 100 degrees. Same here, this must be 100 degrees, and that must be 80 degrees. And if you now compare them, their angles are exactly the same. So what you've done and shown is that the angle BEF, so it's called the angle because it's at the corner between B, the point E, and the point F, is equal to 100. And we've also shown angle equal EFD is equal to 80. Therefore, they must be parallel lines. Question 21. David and Asif are studying the sizes of leaves. Cool, I guess that's leaf scientists. Interesting. Before measuring the leaves, they agreed on the following conditions. The length of the leaf does not include the stem. So we could draw a little sketch of that here. So the length of the leaf is just this bit, not the stem. And the width of the leaf measured is that measured at its widest point. So that's the width of the leaf. Why did they need to agree on these conditions to measure the leaf? Well, they need to agree on that because if they hadn't spoken about it, it could be that David was measuring with the stem, and it could be Asif was measuring the leaf at random positions. So the data would be super varied. It just wouldn't be representative of what they're actually finding. So you could put David and Asif may have used different methods which would invalidate, so make the data worthless, the data. So the findings of David and Asif, they've plotted that on a scatter diagram. So this is part B. There's a nice scatter diagram of lengths and widths. And going to the next page, there is a different scatter diagram. So it says one of the boys collected all of his leaves from one tree. Who was this most likely to be? give a reason for your answer. So you've got two plots. You've got Asif's scatter diagram here. So we put an A next to that, so keep that in mind. And then we've got David's scatter diagram here. Now, if we look at David's scatter diagram, there's like a vague correlation maybe going here, but he's got all different points that are quite spread out. So you can even put a note here, spread out points. But then if we look at Asif's, they're all quite close together. Like if we were to put a line to that, for example, so if we'd put that now, they are very, very close to that line. There seems to be a correlation. So my guess would be, so that's a correlation, and not just the correlation, a positive correlation. So as the width increases, so does the length. So one of them collected all the leaves from one tree. I would guess that's Asif, because if David collects his leaves from random trees, and say some of them trees are young trees, some of them trees are quite old trees, you could see a huge variation in the width and the length. If you collected it all from one tree, all the ages and the amount that the leaves have grown should be roughly similar, which is what we're seeing with Asif's. So to then write it down, you could say David's data is more spread out. Asif's has a strong positive correlation. And then, before I'd even seen and read that question, draw a line of best fit on Asif's scatter graph. So what you're going to do is you're just going to draw a straight line that lines up most well with the data that it's plotted. So say this line, that wouldn't be anywhere near it. This line, nowhere near. We want it to go through as many of the data points as we can. So about here. Asif forgot to include the measurements of one of the leaves on his scatter diagram. The length of this leaf is 7 centimeters. Write down an estimate of the width. Well, now that we've got our line of best fit, if we switch colors, and we know that its length is 7 centimeters, if we look across from the length of, let's get a little bit closer so we can be more accurate. If we look across from 7 centimeters here until we hit our line, and then we follow that down to the x-axis, and then we look at our grid, so between exactly halfway between 6 and 8, so that's 1, 2, 3, 4, 5, that would be 7, and we have 1, 2, so 2 little cubes over, so that would be 7.4. So if we scroll back down to our question, our estimate would be 7.4 centimeters. Question 22. Ivy mixes lemon juice, pineapple juice, and orange juice in the ratio 1 to 2 to 7 to make a fruit drink. Sounds like a very bitter and tart fruit drink to me. But anyway, Ivy has 330 milliliters of her fruit drink in a glass. How much pineapple juice is in Ivy's glass? Well, because we're doing ratios, we're going to figure out, so the parts of the drink are split up into 1, 2, and 7. So the total number of parts would be 1 plus 2 plus 7, which is 10. So out of them 10 parts, we know that 2 of them would be pineapple. 2 out of 10 parts, that's pineapple. So then to find the exact milliliters that is pineapple, you just need to do 2/10 times 330 milliliters. So we can do that in 2 steps to make it a little bit easier on ourselves. So we can divide that by 10 first. So we could have 2 times 33 milliliters. So all of them there is divided 330 by 10. And then I'm going to times that by 2, that's 66. Question 23. The shape below consists of a square surrounded by 4 semicircles. The diameter of each of these circles is 12 centimeters. So if I was to draw a different circle here, a little bit wonky, the diameter is this bit, all the way across the middle. So then if we look at our diagram before we've even read the question, we'll know that these dotted lines here will be the same length as the diameter. So it says work out the area of the shape. Give your answer in the form a plus b pi. So that means that we don't need to actually work out the area of the circle. We can leave it in terms of pi. For the square, we know, so now we know what the sides are worth. For this inside square bit, we know that the area would be d times d, which is 12 squared, which is 144. Okay, so we have the area of our square now. Well, something to note here is you have 4 halves. You have 4 semicircles. Well, if you put 2 semicircles together, that gives you 1 circle. So 4 semicircles is the same as 2 circles. And we know that the area of a circle is pi r squared. So what's r in this case? Well, r is the radius. The radius is shown by a line meeting the edge and going to halfway. So r is half of d, which means it's equal to 6. So each one of our circles is pi times 6 squared, so 36 pi. So our final total area, so give that a t, would be our 144 centimeters squared from our square plus 2 times our 36 pi. So we can write that as 144 plus 72 pi. Question 24. Eisen has a block of stainless steel with a volume of 700 centimeters cubed. The stainless steel has a density of 7.5 grams per centimeters cubed. So for each centimeters cube, each 1 centimeter cube, it weighs 7.5 grams. Eisen says the block has a mass, so that's the weight of the block, a mass of less than 5 kilograms. Is Eisen correct? So we have what the density of our cube is, we have what the volume of our cube is. So then let's work out how much it weighs in grams. So all we'd have to do is get our density, times it by our volume to get our weight or our mass. And if you don't know that off the top of your head, that's perfectly fine. Just by looking at the units here and here, it gives you a hint what to do. So the density has units of grams per centimeters cubed. You're going to times that by the volume, which is centimeters cubed, which means this unit will cancel out, this unit will cancel out, and you'll be left with just grams. So let's do it. If we do 700 centimeters cubed, so that's your volume, times 7.5 grams per centimeters cubed. What do we get? Off the top of my head, I couldn't do 700 times 7.5, but I could do just 7 times 7. So if we first do 7 times 7, we know that that is 49. Okay, so let's do 7 times 0.5. Well, that would be 3.5. Okay, so adding these together, we'll get 7 times 7.5, which is equal to 52.5. You're like, well, okay, well, that's not 700 times 7.5. How is that helpful? Well, if we just add 2 zeros on the end, the exact same as if you were timesing it by 100, we will get 5250. And then remember your units here, so that's grams. So in parts, we've just worked out the 700 centimeters cubed times 7.5 grams per centimeters cubed. So now the last step is, he's given his units in kilograms. Well, we know that 1,000 grams equals 1 kilogram. So our 5,250 grams is equal, so we're just dividing it by 1,000 to 5.25 kilograms, which is greater than 5 kilograms. So we go back to our question. The block has a mass of less than 5 kilograms, Eisen said, but we just proved that it has a mass of greater than 5 kilograms. So we can say now that Eisen is wrong. Question 25. Now this one's a little bit wordy. So it says write 60 is a product of its prime factors in index form. That is a lot of words, but we're going to take this one thing at a time. So let's write 60 as a product of its factors. Let's just find its factors first, and then we'll figure out what the prime factors are afterwards. So if we write 60 as a product of its factors, well, you could have 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10, can't do 7, can't do 8, can't do 9. So we've found all the factors there. Now, which ones are prime? Which ones are the prime factors? Well, a prime number only has 1 and itself as factors. So let's go through each one of these factors and see which ones have 1 in itself. Well, 1, some people might think is, but 1 is not a prime number because 1 doesn't have, only has 1 factor, it doesn't have 2 factors. So the prime number must have 1 and itself. And 1 just has just 1. Doesn't work. So 60, we know it's not, because we just did all its factors. 2, yeah, you just have 2 and 1. 3, that's a prime number. 4 isn't a prime number because you can make it from 2 and 2, not just 1 and 4. 5 is a prime number, 6 is not. And then the rest of these aren't prime numbers. So now we've got, these are its prime factors, 2, 3, and 5. Now that's not the end of the question, because it said write 60 as a product of its prime factors, which is what we've got here, in index form. So writing it as a product of its prime factors, that just means 60 equals something times something times something, which if we just did 2 times 3 times 5, what would that give us? That gives 6 times 5, that gives 30. That's not high enough. So what it means by this index form is each one of these numbers has and can have an index up at the top here. So what it means by index is, for example, squared or cubed, or giving these numbers a power. So it's asking, so with these numbers here, you're going to give them powers. For example, you could have 2 squared and times by something until we get 60. So just timesing them all together, times 3 times 5, we get 30. So we know that we need a bigger number. We need one of these prime factors to have a power. And we actually want it to be 2 times bigger. So you could put, we want times 2 more. Well, to get times 2 more, you could just do 2 squared. 2 squared is equal to 2 times 2. So if we did 2 squared, and then we just did 3, and we just did 5, yeah, that times it out to make 60. 2 squared is 4, times your 3, that's 12, times 5, which we've already shown with our factor pair over here, 5 times 12, that's 60. So then, writing 60 as a product of its prime factors in index form, so it would be 2 squared times 3 times 5. Now we are on question 26. So you're starting to look at the marks and see, okay, you can get up to 5 marks from this. These are getting into the beefier questions. So the question asks, the diagram below shows an equilateral triangle and a square. And that equilateral triangle, that word there, is in bold. So we know that an equilateral triangle has equal sides. So each one of the sides is equal. So we can just draw on the diagram these little dashed lines here. That means that all the sides of that triangle are equal. So now it says, use an algebraic method to find the value of x and the value of y. You must show all your working out. Okay, so we've got our triangle here, we've got our square here. I've just labelled them, so then when I start working things out in the space below, I can keep track of everything. So because we've already said about our triangle that sticks to the triangle, we know that all the sides are equal, which means that 8 centimeters must be equal to 2x plus 3. Well, now let's solve for x. So we're going to take 3 from each side here. So we're going to get 5 centimeters equals 2x. And then we're going to divide by 2, so we can get x on its own. So that gives us 2.5 centimeters equals x. Okay, well that's one of the values that's been asked for. So we can go straight down and write that at the bottom. So that's 2.5 centimeters. Nice. So let's try and get that y. So now we're looking at the square. So a square, we know that all the sides of a square are equal. So we can even put them little dashes in if you wanted to show that in the diagram. So that means that 10 centimeters is equal to 7x minus 5y. Well, at the moment we have 2 previously unknown variables, but that x, we know what that is now. So what we can do is just substitute that value straight in. So we could say 10 centimeters equals to 7, we can put it in brackets, 2.5 centimeters minus 5y. So let's expand out our brackets. What's 7 times 2.5? That's, but here we go, 17.5 centimeters. So we know that 4 times 2.5 is 10. We know that 2 times 2.5 is 5. And because we've got 7, that's 17.5 centimeters. So minus 5y. And just like we did up here, we're going to now start trying to solve for y. So first of all, let's move y over to the other side. I'm going to move 10 that way. So we're going to add 5y and take away 10, add 5y and take away So that 5y is going to disappear, and we're going to take away 10, so we're going to get 7.5 centimeters. And then the 5y is going to appear on this side, and that 10 is going to cancel out. So 5y. Now we just need to divide by 5, divide by 5, so then we get y equals 7.5 divided by 5. So that is just 1.5 centimeters. So I'm going to box that off there. You can write it at the bottom here. Question 27. Now this is a super simple question and there's only 1 mark to get. So simplify 7 square root 2 times 3. So all you will do is times that 7 at the front by 3. So 7 times 3 is 21. So it'll just be 21 square root 2. Question 28. Factorize 3xy squared plus 6x squared y. So for this one, we're going to start with just taking them numbers to the front. So what can both 3 and 6 be divided by and still be a whole number? That's 3. So we're going to put 3 at the front, and then we're going to divide both terms by 3. So 3x to the y squared divided by 3, that's xy squared, plus, so 6 divided by 3, that would be 2x squared y. So now we're going to try and take out just the x terms. So let's just look at the x terms. We've got x on this left term, on the right term we've got x squared. So the biggest index of x we can take out is just x on its own, not x squared, just x. So we can do 3x bracket y squared, divided that by x, plus 2x, so x squared divided by x is just x, y. So now we're going to take out the y terms. So we have y squared and we have 2xy. So both of them have y in it. And we're going to divide by just y, because that term on the right only has one y. 2x, y there, and 3x, y. At that point, we have fully factorized. Question 29. Hans thinks of a number when his number is multiplied by 2.4 times 10 to the 5. So that's in standard form. This is testing you and your knowledge of standard form right now. The answer is 9.6 times 10 to the 8. What number did Hans think of? Write your answer in standard form. So Hans thinking of a number, and so we'll say that this number, we're just going to call it x. We don't know what it is right now. So x, he multiplies it, so x times 2.4 times 10 to the 5, and he gets 9.6 times 10 to the 8. So to get the x, we can now rearrange and say, okay, well, x would be equal to 9.6 times 10 to the 8 divided by 2.4 times 10 to the 5. So how do we do that? So when we're dividing numbers that have indices by each other, so there's 10 to the 8 by 10 to the 5, so we'll do that separately over here. 10 to the 8 divided by 10 to the 5 would equal 10, and then that top number 8 minus the bottom number 5. So the final answer would be 10 to the 3. Okay, so then looking at just our numbers over here, we want 9.6 divided by 2.4. So how many lots of 2.4 are in 9.6? If we do 2 lots of 2.4, that's 4.8. If we do 3 lots of 2.4, that would be 7.2. So then if we do 4 lots of 2.4, we would get 9.6. So that would equal 4. So now we put that together, so we get 4 times 10 to the 3. That's the number that Hans is thinking of. Question 30. So this one's multiple parts, and straight away we could see there's a probability tree. So the question states, Kate is visiting London. The probability that she goes on the train is 0.4, which we can see on our probability tree already. The probability Kate goes to the theatre is independent of her going on a train. So all that means is, regardless of if she goes on the train or not, she's definitely going to go to the theatre. There's no dependency there. So the probability that she goes on the train and goes to the theatre is 0.28. To get that 0.28, it would be the probability that she goes on the train times the probability of the theatre. And then we're not taking anything away. You might see that in equations where they're dependent on each other, but these are independent. So that's the whole equation. Well, we know that the probability of her going on the train is 0.4. So that would be times that probability here that we're trying to find. So if we do 0.28 divided by 0.4, let's make this a little easier for ourselves and times the top and bottom by 100. So we've got 28 divided by 40. Now let's simplify this. So we could have 10, so we're going to divide by 4, so we've got 10, and then we've got 7. So that gives us 0.7. So the probability that she goes to the theatre is 0.7. Okay, so that'll be the first 2 marks. So we can put this in here as well, 0.7. Now the last 2 marks is, we know for probability, the probability always adds up to 1. So the probability that she goes on the train, the probability she doesn't go on the train, that should add up to 1. So 1 equals 0.4 plus the probability she doesn't, which means the probability she doesn't is 0.6. So if we start slotting these answers in, so 0.6, and the same with going to the theatre, that's got to add up to 1. So that probability she doesn't go must be 0.3 and 0.3. So now we're going to calculate the probability that Kate does not go on a train and does not go to the theatre. Well, we already stated that for these independent probabilities, if we're going to say the probability for both of them, we just times them together. So the probability that Kate does not go on a train is 0.6. I'm going to times that by the probability she does not go to the cinema, that's 0.3. So that gives us 0.18. And I know it's 0.18 because 6 times 3 is 18. And then we're going to shift it 2 decimal places that we had ignored in that initial calculation. So question 31. It's asking you to show that the 2 lines below are parallel to each other. So we know that this is a simultaneous equation. But starting by looking at these simultaneous equations and these line equations, they're not in the form of y. So the general formula of a line equation is y equals mx plus c. So y equals m, that's usually the gradient of the line, times x plus c, which is the y-intercept. So let's get both of these equations, we'll call this equation 1, we'll call this equation 2, into the same format. So for number 1, we're going to take away minus 12. So we're going to do 3y minus 12x equals 9. So that's what the equation is now. I'm going to take away that 12x by adding on. So we get 3y equals 9 plus 12x. So then we will get, divide by 3 on each side to get just y. Get y equals 3 plus 4x. Okay, well let's do that with the other equation. So starting with 2y equals 8x minus 13. We just need to divide by 2. We divide by 2 on this side. We get y equals 4x minus 6.5. Okay, so now we've got it in the form of a general line equation. So what's this telling us? Well, if we look at both of our equations, so if I just shuffle my 3 over to the other side there, plus 3, and we can see that our gradients, I'll do this in red so you can see, are both 4. So the gradient of that line, they're both 4. But the only thing that's different is the y-intercept is shifted. So they're going to be two lines with the exact same gradient, so they're going to be parallel, and they're going to be shifted by, what's that, 9.5. So if we've shown that they are parallel. We're now on question 32. The end of the paper is quite literally in sight. Very exciting. It takes 2 hours to empty 8 identical tanks of water using 9 identical pumps. How long would it take to empty 2 of these tanks using 3 of these pumps? So this question, though it doesn't state it, we're making the assumption that all of these pumps work in exactly the same way, and they all pump the water out linearly. So if I was to go, okay, well, instead of 8 tanks, I had just 1 tank, but I still had my 9 pumps, I would know that it would take 2 hours divided by 8. It would be 8 times faster. So 8 times faster. And if I had fewer pumps, so say I had the 8 tanks still, but I only had 3 pumps, and then there's still 9 pumps there. So 3 pumps, 8 tank, then it'd be 3 times slower. So it'd be 2 hours times 3. It takes 3 times as long. So it takes 6 hours. So with this in mind, if we had, so we'll stick to the tanks first. So there's 2 tanks, so the tanks go from 8 to 2. So that would be, so 8 divided by 2 is 4. So there's 4 times less tanks, so it's going to be 4 times faster. 4 times faster. So that's going to be 2 hours divided by 4. But then because there's fewer pumps, so there's 9 over 3, so that's 3 times less pumps, or a third of the pumps as before. It's actually going to take 3 times longer due to that. So if we multiply all of this together, so it's 4 times faster because of the tanks, but then it's also 3 times longer on top of that because of the pumps, we get 3 over 4 of 2 hours, so 3/4 of 2 hours, which is 1.5 hours. So that is the end of the video. So once again, I'm John with Page Tutoring. I hope you enjoyed me going through this paper. Let me know if there's any specific papers you'd like me to work through, if you have any anything you'd want me to cover. and feel free to like and subscribe if you'd like to see more of this content.